Suppose u equals sine inverse x minus y and x equals 3t and y equals 4t cube. Show that du by dt equals 3 upon root of 1 minus t square. We have u depends on x and x and y depend on single independent variable t. Here we can make use of chain rule for derivatives. We have total derivative du by dt equals dou u by dou x into dx by dt plus dou u by dou y into dy by dt. Recall that total derivative or ordinary derivative notation is applicable for u with respect to t because u can be expressed as function on independent variable t alone. And here we can make use of ordinary derivative or total derivative notations for x and y with respect to independent variable t because x and y depend on single independent variable t. Since u have been expressed as function depending on x and y, we have to make use of partial derivative notations for derivatives of u with respect to x and y. We have dx by dt equals derivative of 3t with respect to t, which is 3. We have dy by dt equals derivative of 4t cube with respect to t, which is 4 into 3 into t raised to 3 minus 1, which is obtained as 12t square. Since we have d by dx of sine inverse x equals 1 by root of 1 minus x square, we have derivative of sine inverse x minus y partially with respect to x will be obtained as 1 by root of 1 minus x minus y the whole square. Partial derivative of u with respect to y is obtained as 1 by root of 1 minus x minus y the whole square into derivative of x minus y with respect to y, which has to be written in the numerator. We have derivative of x minus y with respect to y will be negative 1, which is written here. Here we should have calculated derivative of x minus y with respect to x, which is just 1. And thus we obtained du by dt equals this expression. Since both terms in the RHS are having common denominator, we can rewrite the RHS as 3 minus 12t square upon root of 1 minus x minus y the whole square. When you take 3 common from outside both terms in the numerator, it becomes 3 times 1 plus negative 4t square. In the denominator, you can replace x using 3t and y using 4t cube. Thus, denominator is rewritten. And now you can expand 3t minus 4t cube the whole square using the formula for a minus b the whole square. Thus, we have denominator obtained as root of 1 minus 9t square plus 24t raised to 4 minus 16t raised to 6. In this expression occurring in the denominator, if you suppose t square equals x, you can write the denominator as without square root. It becomes a function on x, which is 1 minus 9x plus 24x square minus 16x cube. When you give x equals 1 here, you notice that you get 0 as the answer. Thus, we can conclude that 1 minus x is a factor of polynomial f of x. Or we have 1 minus t square will be a factor of this polynomial. So this polynomial can be written as 1 minus t square into 1 minus 8t square plus 16t raised to 4. Since we have identified 1 minus t square is a factor of this polynomial, when you divide this polynomial using 1 minus t square, you get the other factor as 1 minus 8t square plus 16t square. Thus, the polynomial can be written as product of these two factors. Hence, we have RHS obtained as 3 times 1 minus 4t square upon root of 1 minus t square into 1 minus 8t square plus 16t raised to 4. You can rewrite this factor as 1 minus 4t square the whole square because this, when expanded using the formula for a minus b the whole square, we obtain this factor. When this factor is taken outside the square root, the square disappears and we have 1 minus 4t square common to both numerator and denominator, which can be cancelled. Thus, we have du by dt equals 3 by root of 1 minus t square. Hence, we have proved du by dt equals 3 by root of 1 minus t square.